morning, students. I'm NV Krishna Rao, Assistant Professor in CSC department. I'm handling the compiler design. In the last class, we have seen operator pistons parsing method. Now we'll discuss LR parsing method. Right? Here, the most powerful shift reducing parsing method is LR parsing method. Here, L means left to right scanning of the input. It uses the reverse of rightmost derivation. K indicates the number of lookout symbols it will be considered. By default, we consider as LR1. So L means left to right scanning, R means rightmost derivation, K lookout means it is number of next coming symbols are considered. So LR1 parsing, LR0 parsing. So the number of lookout symbols that we have considered. Here, this is the most general backtracking shift pass reduce parsing. So previously we have seen what is backtracking, but here it is the example for non-backtracking shift reducing parsing method. It is an efficient parsing method for the construction of the parsers. The class of grammars that can be parsed using LR method is a proper superset of class of grammars that can be parsed with the predictive parsers. Right? So this is the LR parser grammars. These are the proper superset of LL1 grammars, right? That can be parsed with the predictive parsers. So an LR parser can detect a syntax error as soon as it is possible to do so, a left to right scanning of the input. So here it will generate the syntax errors as immediately as possible whenever it detect in the input scan. This LR parsers covers more range of grammars. In this the LR parsers are divided into three forms: SLR, simple LR, canonical LR, look ahead LR parsers. These are the three types of the LR parsers: simple LR, canonical LR, look ahead LR parsers. So here these three works same, only the parsing tables are different. They use the same algorithm. These three parsers: simple LR, canonical LR, look ahead LR parsers. These three will work similarly. It uses the same algorithm. Only the difference is the parsing table. Here, this is the LR parsing method, right? The block diagram of LR parsing method. This is the input, right? It uses the LR parsing algorithm. It uses the stack. Here, the stack consists a non-terminal and a state. Always the top of the stack is a state. Always the top of the stack is a state, right? We store the non-terminal along with a state. So this LR parsing algorithm will refer the stack element and input element. Using the both, it will refer the parsing table. SLR parsing table. This is the SLR parsing table. This SLR parsing table has two divisions: action table, go to table. Where action table consists all the terminal symbols and $sign as the column header. Here, the go to table will consist the non-terminals as a column headers. Here, then each rows are represented by states. Each rows are represented by states. Action table consists terminals and dollar sign, and go to table consists a non-terminals. So here our LR parsing algorithm will refer our input symbol and it considered as stack top element, that is state, and it will refer our simple LR parsing table. In the LR parsing table, it will consist two divisions, action table and go to table. In the action table, the columns are represented with the terminals and dollar sign. Here in the go to table, it will be a non-terminals. Right? Each row is represented by respective states. Then here we represent the configuration of LR parsing as a stack and rest of input. Right? Here this is the non-terminal, this is the state, this is the remaining input. SM and AI decides the parser action by consulting the parsing action table. You listen here. SM and AI. SM and AI decides the parser action by consulting the parsing action table. Right? SM and AI decides the parser action by consulting parsing action table. So here initial stack contains S0, the 0 state. Initially the stack contains 0 state. Then a configuration of LR parsing represents the right sentential form. So a configuration of the LR parsing represents the right sentential form. There will be 4 actions in the table: shift, reduce, accept, other. These are the 4 possible actions in the LR parsing table. So what are the 4 actions that are shift, reduce, accept and other? Here shift S says shift the next input symbol and the state S onto the stack. Right? The shift indicates shifts the next input symbol and the state S onto the stack. Right? So here it will indicate that AI will be moved to the stack with another top of the stack with a new state. Next input symbol and the state S onto the stack. Then reduce action. Then a reduce action. What is the reduce is that if the R is the length of beta. Here R is the length of the R is the number of elements in the beta. Here if pop the double the length of number of elements in the beta, right? Then push store elements A and S, right? Where S will be obtained by refining the goto of SM minus R state and non-terminal state on the stack top and A is the non-terminal of the production. Right? So the non-terminal of the production and top of the stack state is deferred in the go to table, and a new state is formed. If here we have to pop the double the number of we have to pop double the number of length of beta, and we store this a into the stack, and this new state s. By referring go to table s m minus r gamma a, we get a s state. We'll store the s state and the non-terminal of the production, left side of the production, a will be stored under the stack. Here, another two actions are simply accept and so here same thing, the reduce action we are explaining once again. So here length of beta, if double the elements, number of elements in the length of beta will be popped from the stack, right? So here beta is, if we assume r, then 2 of beta elements will be removed, because each non-terminal is associated with the state. So the state and non-terminal both are popped from the stack, right? It's clear. If the length of beta is r, then 2r elements are removed from the stack, because each non-terminal is associated with the state. So both of them will be removed or popped from the stack. Then we'll refer the top stack element and non-terminal of the production and used to find s. The state will be stored here, right? So in fact, y1 to yr is a handle that will be replaced with the variable a. It means that y1 to yr is the handle that is replaced with the non-terminal a, right? So that is a reverse of right sentential form that is used in the bottom of parsing method. Here, first we'll discuss what is the SLR-Parsing method. Later, in the next class, we'll discuss the construction of the SLR-Parsing method. Now, here, the productions 1 to 6 are given. The productions 1 to 6 are of the grammar, it is given. Now, for every problem, we will add a new production E dash use E. Right? This is the grammar that is given. For this grammar, we always add E dash equal to E. And now we are considering the SLR-Parsing table, the first method of LR-Parsers, and we will discuss how to perform the SLR-Parsing. Right? The SLR-Parsing table, it consists action part and go to one. Right? So here go to always represent non-terminals as a column headers, and action will represent terminals as the column headers. And these are the states 0 to 11. Now, here we are discussing the SLR-Parsing method. How to use this parsing table to perform the parsing of the input. So, here S will indicate shift action, and the state number 5 or 4 are stored into the stack. Here, the juice indicate the juice action, or indicate the juice action. It will reduce the production number 2. Here R4 means reduce the production number 4. Right? R2 means reduce the production number 2. Okay? R6 means reduce the production number 6. R4 reduce production number 4. Here reduce the production number 1. It is reduce production number 3 and reduce production number 5. R indicate reduce the production numbers respect to number. S means shift action. The S is followed by some number. That number also move to the stack. Right? Always the top of the stack is a non-terminal. Now, using this table, we'll pass our input string. Here, the first method is a simple SLR passing method. Now, always the stack with initial state 0 and the input symbol, input string end with $sign. Right? Input is end with $sign. Stack is with a 0. Now, 0 and ID. 0 and ID is for the table. What is the 0 and ID? 0 and ID, it is given as S5. Right? Here, this 0 and this ID is giving as S5. Shift 5. Shift this ID to here and move this 5 to here. Always the top of the stack should be a non-terminal state. So that ID terminal is moved to the stack and it is followed by the terminal that state 5. Now 5n multiplication. 5n multiplication is for the table. 5 multiplication. Right? Now we'll refer the table. 5 multiplication is R6. 5 and multiplication is R6. Right? Reduce the production number 6. Reduce the production number 6 FQ's ID. Right? Then, how many elements are in the production right side? 1 element. So, pop 2 elements. Since 1 element, so pop 2 elements. Then, after popping 2 elements, what is the top of the stack? Is 0. Top of the stack is 0. Then, what is the non-terminal here? F. The non-terminal of the production is F. 0 and F from the table. What is a 0 and F? 0 and F is a 3. From the table go to 0 and F is table 3. So, go to 0 F and give me 3. So, store this F into the stack and this 3 also into the stack. F into stack and 3 also into the stack. Listen here. the number of elements on the right side of protection is 1. So pop the double the number. So ID and 5 both are popped. Then from the stack. Then it results to the 0 as the top of the stack. 0 and F refer that non-terminal F and 0 top of the stack will resulting a go to table will result the new state number is 3. So store the F and also 3 into the stack. Store the F and 3 into the stack. Right? Now what we have? Now we have 3 and multiplication. Now we have 3 and multiplication. What is the 3 and multiplication? 3 and multiplication is R4. What is R4? Reduced production number 4. Right. Here which gives T gives F. Right? T gives F. Then how many elements are there? The number of elements are 1 on the right side. So pop 2 elements from the stack. What are the 2 elements? Remove F and 3. Remove F and 3. What is this now state? The state is 0. So that state is 0 and T is the input. T is the non-terminal of the production. We store both of them into the stack. Right? We store a T and this output state go to. That go to action given a 2 is a state. We will move this T into the stack and also move 2 into the stack. Now 2 and multiplication. Now 2 and multiplication. What we have? 2 and multiplication S7. 2 and multiplication S7. Shift 7. Move multiplication and also 7. Then ID and 7. 7 and ID. The 7 and ID giving 7. ID is giving S5. So simply 7 ID is giving 5. Okay. So here ID 5 and plus. What is 5 and plus? Reduce F gives ID. 1 element. So remove 2 elements. Then 7 and F. 7 and F giving 10. So store F and 10. Now refer 10 and plus sign. Refer 10 and plus sign. So what is it giving? It is giving reduced production T into F. How many elements? 3 elements. So pop 6 elements. Pop 6 elements. Now what is the 0 and T? 0 and T is 2. So move this 2 into the stack and this 2 also stack. Now we have 0, T and 2. Now refer 2 and plus. What is 2 and plus? E gives T. How many elements? 1 element. So pop 2 elements. And 0 and E giving 1. So E and 1 we have. Now 1 and plus sign giving as 6. Shift 6. So simply move plus and 6. Now 6 and ID. 6 and ID as 5. Right? So simply move ID and 5. Then 5 and dollar. 5 and dollar reduced by F equal to ID. How many elements? 1 element. So pop 2 elements. So pop 2 elements. Now what is it giving? 6 and F. Right? 6 here, this F. 6 and this F will giving 3. So store F and 3. 3 and dollar. 3 and dollar, which is 3 gives F. How many elements? 1 element. So remove 2 elements. Remove 2 elements. Then 6 and D giving 9. Right? 6 and D giving 9. So how many elements once again? 1. Right? 1 element. Okay. Right? So we are storing T and 9. Now 9 and dollar. 9 and dollar. What is giving? 3 elements. 3 elements means what? Remove 6 elements. Now E and this 0 in the go to will verify which is giving 1. Store this E into this stack, this 1 into this stack. Now 1 and dollar. What is 1 and dollar? 1 and dollar in the table indicating accept. Right? 1 and dollar indicating accept. This is the SLR predictive SLR parsing method. It is one of the bottom up parsing method. So in the next class, we'll see the construction of predictive parsing SLR parsing table. So in the already we discussed how to perform the SLR parsing in today's class. So we'll see the construction of the SLR parsing table in the next class. Right? So one of the efficient bottom-up parsing method is SLR-Parsers. In the SLR-Parser, the first method is simple SLR-Parser. So now we have seen in this class, so what is the SLR-Parsers? What is the SLR parsing method? So now I am closing this class. We'll continue the construction of the SLR parsing table in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.